Week 2, Lecture 2, Flow Control. If you've worked with an OOP language before, you should be somewhat familiar with the concept of looping. Branching refers to a method of controlling what particular line of code should it execute at a given time, or as a result of the given condition. It is a kind of loop as well. There are three branching techniques in C#, a ternary operator, an if statement, and a switch statement. A ternary operator, as we saw in our discussion last week, is a way to perform a comparison. Test, result if true, result if false, with test being evaluated for the Boolean conditions true or false. Depending on the result, the code may branch or execute different actions using the if and else statements. Code structure for such a comparison is if, open parentheses, test, close parentheses, code executed if test is true, else, code executed if test is false. The code with the variables and conditions added on the right looks like string, result string, if, open parentheses, my integer is less than 10, close parentheses, result string equal less than 10, else, result string equal greater than or equal to 10. Switch statement also executes code based on a condition that allows the testing of more conditions at a time than a simple if statement. While limited to discrete values, it can save a great deal of work in the right circumstances. For example, switch test variable, open curly bracket, case, comparison value 1, code to execute if test variable matches comparison value 1, break, case, comparison value 2, code to execute if the test variable matches the comparison value 2, break, ellipse, case, comparison value n, code to execute if the test variable does not match comparison values, close curly bracket. You can use as many case statements as are needed. And note in the final statement there is a default action if you have a case statement that fails to match. Unlike C++, execution cannot flow from one case to another. The break statement allows each case block to be executed separately. Case statements can be stacked to allow them to flow from one to another, however. Switch test variable, open curly bracket, case, comparison value 1, code to execute if test variable matches comparison value 1. Go to case, comparison value 2, case, comparison value 2. Code to execute if test variable matches comparison value 2. Break, ellipse, close curly bracket. Adding a breakpoint with the default or return helps ensure there's always a valid path to execution. Loops allow for a single statement to be executed as many times as necessary. Rather than writing the same code multiple times for a single variable change or until a condition is met, as in the example on the left, the process can be streamlined using the loop on the right. Do loops execute code until the criteria noted in the Boolean test is fulfilled? For example, true or false, yes or no. Do, curly bracket, code to be looped, while, test. A while loop is similar, but unlike the do example above, takes place at the beginning of the loop instead of the end. While, test, open curly bracket, code to be looped, close curly bracket. A for loop executes a specific number of times and uses a counter. It needs a starting value for the counter, a condition for the loop and counter, and an operator for the counter variable at the end of each loop. For, open parentheses, initialization, semicolon, condition, semicolon, operation, open curly bracket, code to loop, close curly bracket. Remember, without some method to terminate, loops can become infinite, which ties up system resources. While one can manually exit the program, an accidental infinite loop is nearly always undesirable.